Assalamu alaikum. Hello viewers. Today we'll be discussing about the design and a simple simulation of an I-beam, and the design we'll be doing in this Cads software SolidWorks, and some simulations will be done using Ansys 15. So for some introductory informations, let's see why I-beams are made. I-beams are made usually to maximize the usage of materials, and in solid mechanics, structural mechanics analysis is found that the maximum bending stresses are at the two edges of a beam. So it means if we have a beam connected to two poles and we have a load in the intermediate section, that means the maximum beams will be on the two sides of the cross section. So to reduce the material cost and maximize the efficiency, these types of sections are being used in structural situations, structural designs, and we will be discussing some of the basic concepts furthermore when we design it. So for the time being, we select the front plane, make a sketch on it, and for specifications we'll be using standard American W36 by 230, and this means that the height or the depth would be 36 inches long of the I section, and each section would be 230 pound per feet weighting, and the width of this would be 16.5 inches, and the thickness of the I sections would be 1.3 inch, and the web thickness would be 0.8. The web is called the connecting part of the two sections. These are called economic sections, as I section, T section, S or W, whatever you need, and the details would be found in any of the structural mechanics books. So for the time being, let's get started. We just select a line and use it as a construction line, and select the line. Let's just make it a rough eye for the time moment. There. Now we just use some dimensions, since I have mentioned about the sections, and let's just turn it into IPS, edit the section, turn it 16.5, this part is 32. Let's just further to make some relationships. Make horizontal and collinear, and this line and this line as collinears. Much better. And say this one and these two are symmetric. Alright then, now for the thickness, the web, this connecting part is called the web, and this does not usually take any of the bending stresses, so it's pretty much thin compared to the other parts. So this part is 0.8 inches according to standards, and we make this line and this line as equal, and this section would be 1.3, make these 4 lines equal there. We can just pull this one a little higher so that we could just add relationships and make things a little more easier. So let's say we want this one, this line, and this one as symmetric. For more assurance, we just add this relationships as symmetric as well. The much better section. Hide the relationships. Make these two equal. So is these 2 parts. Let's set it to 7.85 for the time being. Alright, this is our standard sketch, and all we need is just to extrude it. These are usually seen in high-rise structures, steel structures, and this length, the amount you lengthen this in this dimension, is critical for whether you use it for axial load or bending loads only. If you use any kind of loads on this axis, it would tend to bend because this has a least radius of gyration, and the bendings would be in these 2 sides, on the opposite sides like this, because these would turn into something slender, and you would just, for long beams, the critical slenderness ratio would be exceeded. So we have to ensure when you design that it just acts as a beam, and the length, that if we use the material, steel material, that would be 230 pounds per feet. So let's just say we use this as 84 inches as 7 feet long. There, that's our eye flange. And now we'll just save it as I beam, and to analyze it, we'll just today be using the static structural elements. For Ansys, we just pull this static structure, click on it, and pull this out on this project schematic, and the toolbox is showing the elements that you have licensed of this product. If you don't see any of the products seen on your toolbox, then just you need to reinstall your license manager, or you might just not have the license for that particular operation yet now. So we have the engineering data. By default, Ansys has some engineering data installed in it, and it chooses structural steel as default, and if you want some other materials, you might just add it from anywhere in this place. Hyperstatic, a really large library it has available for you. Physical properties, you might just change any one of it inside this one, and if you want some more of the elements, you might just look for things like this. And even there are elements like engineering data sources, and you need to choose from materials what you need: fluid materials, some general materials. Let me just shrink it out. Air, polyethylene, whatever you choose, depending upon the list they will be shown here. Elastomer samples, whatever it is, but we will be just analyzing for the time moment only the structural steel. So that's it. So we just turn it off. You might just like to update it every time you just change anything of it. Now for the geometry, we just import the geometry, and since it's open, it's just importing it. Now for the model, we edit it, and the speed is going to be depending upon your system. The more higher the systems you have, the faster it will analyze. This is called Ansys Mechanical, and here we analyze mechanical elements. And out here in geometry part, you could have made some 3D models as here as well. Ansys has its own CAD environment built into it, and you might just design, if you want, might just design anything from it and using this edit geometry or replace geometry, whatever you like. But for the time moment, as it's easy for me, we'll be just using SolidWorks to design our CAD file and import it. So let's just select elements that need to be applied. For the time moment, we need to apply two fixed supports. Since it's going to be acting as a beam, there will be two fixed supports, and for that we need to apply those fixed supports. Say insert fixed supports, right click on static structure, insert fixed support, this face, and then select apply. And we just add another fixed support. On this face. So there we go. So you can see the two fixed supports where you have fixed them with this surface, and the other one is in this surface. Alright, now since these two are fixed, now we just apply a simple load. You may apply variable load, you may apply single load, whatever you want, even imported loads as well. So we could just add force on this surface, and the magnitude you could have just choose how to apply it using components, and define the definitions are used by you. Let me just say for the time being we use components, and we just only use Y component as to be, say, 50 newtons, and for the other two parts we just leave them 0. And for that we need to insert what solution informations do we need. Let's say we want the maximum deformation and the maximum shear stress, von Mises stress, so, and after that, before that, we need just to generate a mesh. Since these softwares are usually based upon numerical calculations, and you might just, if you want, hover around, look for the equations that are used in these software packages, and for the time being we're just happy with these results and press solve. Since our solution is done, now we can see the total deformation, the equivalent stresses are maximum on the other sides, and this plane, since we had applied the stress on this side, and this part is quite deformed, maximum shear stress also in this plane. And you may scale the visuals up to you, and since it's a structural steel, deformations are going to be very little, but the degree that you need to see is, that's why we magnify things, right? Total times magnified, there's the difference. And you see the load's been applied in this side, so these two sides are automatically raised. So this is the way, basic ways that we analyze structural steel, static structure in Ansys. And you might just want a hover around to change any parameters to get other results as you wish. So try to insert whatever you need, even there are fatigue tools as well. And the best part of this Ansys Mechanical is that whenever you choose this view mechanical wizard, it helps you through anything that you need. And in these cases, whatever you choose, you can reach the situation that you need and the inputs that you need to implement to get your expected results. So play with them, go around and discover things that you need in your life and in your designs, and you may just analyze them as well. So this is the simplest way and the simplest case study of an I-beam, and we will be uploading some more other videos and some advanced and fluid interaction forces as well in pretty short interval, inshallah. So that's it for now. Like, subscribe and share if you like this video. Thanks for watching.